So you just put a dot between Kamiar, Kouzekanani, and tamusisi.edu. That's my email address in case you want to contact me later. Kouzekanani, you say it a few times. A few of my former students, or present students, are here, so you can ask them to say how you say Kouzekanani. I'm in College of Education. I'm an old-timer. I've been doing this for 31 years now, so not here, but overall. I did it last year, and so my focus is on quantitative methods. I'm not going to get into results section. Results section, each one's results section is going to be different. And then I have one example of a chapter 3 methods. I just copy from one of my students' dissertation. So I will go pretty much non-stop for 90 minutes. Okay, fasten your seatbelt, and pretty much I'm going to cover my 3-credit doctoral course in methods in about 90 minutes. So the highlights, the most important part of the course. So my students who took the course with me last semester, this is a review. The rest of you, you have heard some of it before, some are new to you. And I couldn't do it in 60 minutes. That's what I asked for, 90 minutes, and hopefully we'll be done in 90 minutes. Feel free to stop me and ask questions, or if you need a more explanation of something that I talk about. So let me make sure that this thing works for me. We are scientists, or trying to be scientists, so we do scientific inquiry. Pretty much it's divided into 4 sections. Conceptual phase, this is probably what you have been doing, those of you who are working on your doctoral dissertation. The topic, chapter 1 of a dissertation proposal, the one which would require of you to spend lots of time in the library or review the literature, to come up with your research questions or hypothesis, which must be approved to begin with by your chair, and then you move on. And also that's where you identify the theory which is going to support your study, because the doctoral dissertation must be theory driven. Without a theory, it's not going to fly. Then the methods phase. So that's the focus of this session today. And obviously emphasizes on quantitative methods. Essentially chapter 3 of a dissertation proposal, and then later of a dissertation. How many of you are doctoral students? And then masters? And then you have to do thesis for your same thing. Whether it's a master's thesis or a doctoral dissertation, it's pretty much the same. Empirical analytic phase, this is after you have collected the data and analyze and write the results, pretty much chapter 4 in a typical doctoral dissertation. And then the dissemination, hopefully after you're done with your thesis or doctoral dissertation, you want to do something with the document. You have to, especially those of you who plan to become university professors and all that, publishing, making presentations. So again, my focus is on this today. And then as part of this, I'll talk about the data analysis. And then at the end, I give you a chapter 3 of one of my former students, methods part, so you can use it as an example when you have to write yours. Okay, I have to get used to this thing. It's in the corner. Zillion years ago, when I was a doctoral student, we did lots of reading on Curlinger. One thing I still remember after more than 30 years is as to what is scientific research. In scientific research, the four major characteristics of scientific research being systematic, control, empirical, and critical. Systematic, so it's a step-by-step process, and you document it. Why do we want the study to be systematic? So that the study can be replicated. And there are two types of replications. One is what we call direct replication. One is what we call systematic replication. Direct replication, you are going to replicate the study as the original without any changes. When you do that, your purpose is to confirm. Like you are going to replicate the study that I did 2 years ago. And then if you come up with the same results, then you are going to confirm what this other researcher found. Systematic replication, you are going to make a change. For example, the original study was done with Anglos. You are going to replicate the study here in South Texas with Hispanics. You do that to generalize. So if the intervention worked with Anglos in this original study, you replicate it with Hispanics, and it works, then you can generalize it to Hispanics. And there are people who do replication as a doctoral dissertation, by the way. So, well, my doctoral dissertation replicates the study that, or master's thesis, and a study which was done earlier. So that's what we mean by systematic. Control, what do we mean by control? We want to control for extraneous or confounding variables. So what are these variables? These are the variables which are correlated with the outcome, but they have nothing to do with what you are doing. So then you have to control for that, to conclude at the end whatever happened because of my intervention. Not because I had two groups of kids and there was a reading intervention and one group was much smarter, their IQ was higher, and that's the group received the intervention, also did better than the comparison group. Then the question is, was it because of your intervention or was it because they were smarter to begin with? So we have to do that. First, you have to identify the potential confounding variables, because it's not a guessing game. You cannot just, I think age is a confounding variable. That's not how it works. You have to prove it. And how you prove that, that's when you get into statistics. You have to do covariate analysis, for example, and show that age is correlated with the outcome but doesn't have anything to do with the intervention. And then you adjust. Every now and then we hear like economy, inflation adjusted for something. Whenever you hear the word adjust, it means they have done some control of confounding or extraneous variables. So needless to say, we have to do it in research too. Whether you do an experimental intervention, whether you do a causal comparative ex post facto studies. I have had a number of students. I have 7 over 100 dissertation committees on this campus, chaired 45 of them. So I've seen this thing in real life when we collected the data, do the analysis at the beginning. Gee, my group is doing better than the comparison group. Hold on a second. Let's just look at the variables that you have and then identify the confounding variable, adjust for it, that the difference that you saw earlier disappeared. Why? Because in this group, one group, you have more at-risk students compared to the other group. When you adjust for the risk status, the difference disappears. So you have to be mindful of that. Empirical, you have to have hard data at the end. And critical, that's when, in the context of your thesis or doctoral dissertation, you have to defend it. So your dissertation committee or your thesis committee has to approve the document, the study. And then later you would like to get it published. And I'm sure you all know that we are interested in peer-reviewed publications. Don't waste your time on reading reports which have not been peer-reviewed, because you don't even know whether what you are reading is accurate or not. So these are the four major components of scientific research. The research is either applied or basic. Applied research, you do it to solve a problem. You identify a problem, then you do your research to solve the problem. Relapse from substance abuse use. That's how you're going to prevent it, for example, or dropout from school. That is applied. Basic research, you do it for the sake of knowledge. Essentially, you test hypotheses, or you may develop hypotheses. And depending upon your field, your thesis or dissertation committee chair, and you can do either one. As long as you can show that it's going to make a contribution to the field, it will fly as a topic. The quality of research, we can use 3 criteria to evaluate the quality of research. Generalizability, to whom you can generalize. And lots of research we do in social science, applied behavioral sciences, education. That generalizability is very limited because we don't work with random samples. You end up with non-probability sample. But that's one factor. And this is something you have to address when you write your proposal in the subject selection. And then if you know ahead of time, definitely, all the students that I have had all these years, the extent of validity, generalizability was limited to participants. And you specify that. When you write your proposal, you usually have a section called delimitations, limitations, assumptions. Let your audience know, or at the time of proposal, the committee know that it will be limited to the participants. Trustworthiness, people accepting your study. For what you do here for your master thesis or doctoral dissertation, that's why you have a committee. You have a chair, at least 2 other members. And at the doctoral level, you even get a GFR representative from the graduate school. So at the minimum, you have 4 members, maybe the 5th one. I'm not in favor of more than 4 committee members, 3 plus the GFR. But these are the ones who are going to approve your study at the end. And then the importance of the study. When you write your proposal, chapter 1, you have a section called significance of the study, right? So when you write your proposal, in the significance of the study, you write what you hope to achieve by doing your study. When you are done, then you usually have to revise your significance of the study, because you know what happened and you know what you could do with the study. When you write a proposal, you can go a little wild. Okay, I'm going to do this and this and this. Probably your chair is going to ask you, calm down. You cannot do all this in a doctoral dissertation or a master's thesis. You have to be realistic. And so essentially, my students, I tell them, ask yourself, so what? Answer the question of, so what? If you have a good answer to your so what question, you can convince the committee that this is a good topic worth being investigated. Another thing I always remember from Kellinger until as long as I'm doing this kind of work is his max mean con principle. This is the most beautiful definition for scientific quantitative research. He summarized it in this term, max mean con. We do research to maximize true variance, to minimize error variance, to control for confounding or extraneous variables. This is research. This is quantitative research. And anyone with a minimal understanding of quantitative methods understand what I just said. Maximize true variation, minimize error variation, control for confounding or extraneous variables. In a simple correlational study, at the beginning, you don't know what's the relationship between x and y, correct? Because what is the null? There is no relation. Relation is 0. So then you come up with your correlation coefficient. You square that. That's the explained variation. So you can have a correlation coefficient of 0.2, for example. And if you have a large sample, it's going to be a statistically significant. But 0.2 squared is 4%. So it doesn't have much of practical significance, but has, for example, a statistical significance. So we want to maximize the true variation, minimize the error variation, control for extraneous confounding variables. Any question about this page 1 before I move on to page 2? I have 9 pages. This is going to drive me crazy. So in the conceptual phase of the study, at chapter 1, you come up with a statement of the problem, and then the specific objectives of the study, your research questions or the hypothesis that you would like to test. Once you identify those, then you have to decide on the design, what kind of a quantitative study you are going to do. Generically, you can divide them into 3 categories. One is descriptive studies. You don't test hypotheses. You don't even know what is independent, what is a dependent variable. You just want to report the status quo. Is it appropriate for doctoral dissertation? Yes. So don't assume just because the study is descriptive, it's not going to fly as a doctoral dissertation topic. Of course, it depends upon, at the beginning, your chair, and then also the committee. But there are lots of descriptive studies which are good, resulted in good information. Sometimes when you cannot even identify independent, dependent variable, you need to start with a descriptive study, then to use the data to suggest a hypothesis. So that's one end. The other end is experimental research, when you establish cause and effect. If this, then that. I'm going to talk about this a little more. And in between, we have what we call ex post facto studies, correlational studies, causal comparative studies. We do them to either explain or predict. You cannot draw any causal inference because you don't manipulate your independent variable or variables. And you are doing more than just describing as to what happened. So let's talk about some of this. Experimental versus non-experimental. In experimental research, you manipulate at least one independent variable. The three essential ingredients of experimental research are manipulation, control, and observation. So you manipulate your independent variable. Say, for example, teaching method. That's your independent variable. And you manipulate it. One group receives face-to-face instruction. One is hybrid. One is online. You have manipulated the variable. So you do not want to confuse the variable with the levels of the variable. Example I just gave you, there is one variable, teaching method, with 3 levels, face-to-face, hybrid, and online. So you manipulate. Then you have to control. I just talked about control. Control for confounding or extraneous variables. So you can, at the end, say whatever happened because of my intervention, not something else. Observation, don't confuse this observation with the observation that you have heard of in qualitative research. In the context of quantitative, observation is you do the measurement. Non-experimental is the opposite of experimental. You do not manipulate your independent variable. You cannot draw any causal inferences. In the context of experimental research, we distinguish between true experiment and quasi-experiment. In both, you are going to manipulate your independent variable, and in both, you can draw causal inference. In true experiment, you do what we call random assignment. You randomly assign subjects, for example, into the experimental group and the comparison group. And if you can do that, random assignment controls most threats to the internal validity of experimental interventions. The problem is getting permission to randomly assign is not that easy. So what are we going to do if we cannot do random assignment? The principal of this elementary school is going to let you do your study with first graders, but it's not going to let you randomly assign them into your experimental group and the comparison group. But the principal would tell you, I have 2 first grades, 2 classrooms of first graders. I give them to you. In other words, you are going to, oops, what did I do? No, I'm okay. This is the first time I'm wearing this stuff. You work with what we call intact groups. You flip a coin. One is your experimental group, one is the comparison group. You are manipulating, but there's no random assignment. The teaching method I talked earlier, face-to-face, hybrid, online, and you want to do it here at Tammuz CC, okay. Come up with a course that you can have 3 sections of the course. One section is hybrid, one section is face-to-face, one section is online. You don't randomly assign the students. They go and sign up. But you have manipulated the teaching method. You do not want to confuse the random assignment with random selection. Random assignment has to do with what we call internal validity. Where is it?
Second line.
Yeah. Internal validity, what you are saying, when you claim your study has internal validity, what you are saying is whatever happened because of my intervention. So random assignment increases the internal validity of the study. Think about it. If you randomly assign subjects into the experimental group and the comparison group, there is no reason for you to end up with one group consists mainly of females and one group consists mainly of males, which could make gender a potential confounding variable. If you do random assignment, there is no reason for you to come up with one group which is much older than the other group. But again, there are times you cannot do that. You have to work with intact groups, It's not the end of the world. You are going to continue doing your study, but you be mindful of the fact that you may have potential confounding variables. And you have to tend to them later. Random selection has to do with external validity. External validity, to whom can you generalize? So don't confuse these two. For example, you are not selected at random. You are here tonight, this afternoon, because you decided to come to this workshop. So how many of you are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The 14 of you are not representative of the population of graduate students at Tammuz CC, correct? I cannot generalize anything from this group to the population. But I can get permission from the IRB to do a true experiment, randomly assign 7 of you into my experimental group and 7 as my comparison group, correct? If I have the permission, I can do that. Randomly select, okay, you 7 go to this next door, we do the intervention there, and then the rest of you are my comparison group, we do something else. Because you are not selected at random and you do not represent the population, the study is limited in external validity. But because of random assignment, the study is high in internal validity. Clinical trials, you have heard of them? Mm-hmm. How do they identify subjects? They ask for volunteers, correct? Yes. They put the ad in a newspaper, a specific criteria. Because even if they randomly select, they could end up with a whole bunch of people who don't meet the criteria to be in the study. And then once you volunteer to be in a clinical trial, then they ask you to report to the intervention site at 5 o'clock in the afternoon on Friday. The intervention is during the weekend. Saturday, Sunday, Friday night, you are almost in a jail because they control what you eat, how much you sleep, and all that. So those clinical trials, for example, they are very high in internal validity but low in external validity, which is why, for example, it takes months, years sometimes before FDA introduces a new drug to the market. Because you keep hearing, we have to replicate the study to make sure that we can generalize it. So random assignment, random selection. If and when you claim you have done either or both, just make sure you have done them. Because once we read or you talk about it, then if you really didn't do the randomization, it would show. You are not obligated to do random assignment, or you are not obligated to do random selection. If you haven't done it, you couldn't do it, acknowledge it. There are 3 lies I always tell my students. Check is in the mail, I'm from the government here to help you, and the 3rd lie is randomization. So, and I have had my share of people coming and saying, and then I say, okay, tell me how you did that. And then when there is an explanation, it was not random assignment, because you had a 9 o'clock session and you had a 5 o'clock session, and anyone could sign up for 9 o'clock or anyone who could sign up for 5 o'clock. That doesn't mean you did random assignment. Very likely those who could sign up for the 9 o'clock, they were older people who didn't have to work, so they could sign up for your 9 a.m. session, 5 o'clock or 6 p.m. These were older, younger students, professionals who couldn't. And now they are there because after work they can report to the experimentation. Where is this thing? Oh, it's here. Okay. So enough about experimental. Yes?
Would you like me to work the mouse from here, if I can?
Yes, but then, okay. I'll tell you go down.
Okay.
Does this work? Anyways, you be mine.
Okay.
What do you want? This?
The mouse.
Okay.
If that works, if not, I'll give it back to you.
Okay. Causal comparative, also called ex post facto, after the fact. You don't manipulate the independent variable. But you identify, for example, kids who dropped out of school, compare them with kids who did not drop out of school. So that's why it's called causal comparative. So don't let the word cause kind of deceive you, that you can draw causal inference. You can't, because you are not manipulating the independent variable. In the College of Education, I'm in the educational leadership program. This causal comparative has been a very popular design for our students, because many use existing data. And my student who is writing her chapter 4 as we speak, her study, she compared 4th and 5th graders who had recess in their school versus 4th and 5th graders in her comparison group, those who didn't have recess. So she didn't manipulate that. She cannot draw any causal inference, but she identified 2 schools with recess and without recess to do the study. Number of them, PBL, problem-based learning versus non-PBL. Identify those who went through treatment for substance abuse and relapsed, compare them with those who didn't relapse. So that's the causal comparative studies. You have independent, dependent variables. You can test a hypothesis, but you cannot draw causal inference. You can either predict or explain. Okay, go down. Okay, yeah, that's fine, keep it there. So that was causal comparative. Then we have correlational research. You all know what correlational studies are. You correlate variable with variable, variables with variable, or variables with variables. In other words, you can have a simple correlation, 1x, 1y. You can have several predictors and 1y. And if you want to be more sophisticated in your approach, you can have several predictor variables and several outcome variables. Correlation does not necessarily indicate causation. So you have to be careful in the correlational study. You are not going to suggest any causation. I had an article to review for a journal, and they had done a pretty good job, but there are too many causal inferences. They had looked at variables like education, occupation, and then said this occupation had an effect. Or level of education had an effect. That's a wrong conclusion. This is not being picky. You do not manipulate, for example, gender. You do not manipulate level of education. When you send out a survey and ask questions, what was your highest level of education? High school diploma, BS, MS, doctorate. So simple correlation, 1x, 1y, and then you have multiple correlation, several x's and 1y. In terms of the statistic, this is what you learn in first course in the stat, like introductory statistics. You learn about multiple correlation in, say, intermediate course in statistics. There is one when you have several predictors, several outcomes. There's a technique called canonical correlation, and you learn about that in advanced classes. I don't get into that, but I have had my years here, I had 2 students actually who had to do canonical analysis for their doctoral dissertation. The last one was a couple of years ago. He looked at the STAR reading categories, several reading categories, several math categories. So something like that calls for a canonical correlation. I remember he was my student, and when he was working on his proposal, I talked earlier, the research questions, and I said, okay, what you want to do calls for this new technique that you don't know it. We don't teach it I don't teach it in the 2 stack courses that I teach in the College of Education. You have an option. You can either learn the new technique or change your research question. He said, I would like to learn the new technique. And I worked with him. By the time he finished his doctoral dissertation, he knew more than anyone else on this campus probably about canonical correlation. It's pretty sophisticated, but he understood it. And then he went to APA convention in Toronto, Canada, and presented his doctoral dissertation. It was a big deal to him. For the first time, high school assistant principal in South Texas. I think he still is in Callahan High School, going to another country to present his doctoral dissertation in a very major conference. The point I'm trying to make is, if you're passionate about your topic, and then your methodologist, a stat person would tell you, okay, to do this, you have to learn this. Before saying no, think about it. And if the person is willing to work with you, take the offer. Learn the new technique. Don't throw it out because, well, we didn't cover canonical correlation in the stack courses. Some other techniques. Survey is descriptive. We do it to explore. Again, don't automatically assume that survey research is not appropriate for a doctoral dissertation or master's thesis. No. Come up with the idea, talk with your chair, and then if it's going to make a contribution, it will fly as a study. Census, you know what census is, studying all subjects. It's unlikely for you to do a census study unless the population is very small. It doesn't make sense to draw a sample from a small population. Then we have prospective studies and retrospective studies. Just to make sure that you all know the difference. Prospective studies, you start now and you move forward. You follow your subject over time. From the first week of the school year to the end. So you may decide to pre-test them and then do a 3-month follow-up, 6-month follow-up, 9 months follow-up. That is prospective or longitudinal. You can examine developmental changes. Okay? Retrospective, you start now, you go backward. You rely heavily on recollection of past events. This is when you send out a survey or interview, and then, for example, you ask the subject, okay, I'm going to read to you the list of these stressful life events. Think about the past 3 months, tell me which one you experienced. And then I go through the list. She's going to endorse four of them. Then I said, okay, during the past 3 months, which of these was most stressful? Of the 4, she picks working on my doctoral dissertation. Okay, now focus on this stressful life event. Now I'm going to read to you the ways of coping checklist. There is an instrument that actually measures your coping skills to find out whether you're active coper or passive coper. Focus on this and tell me how you cope with this event. That's an example of retrospective study. So as a researcher, I'm relying heavily on the recollection of past event of the subject. Whether you do it in person or you send out a survey. So we do lots of retrospective longitudinal. Before you decide to do a longitudinal study, make sure that you can afford spending a couple of years, a year or so, because it takes time. So I have had one student in my 14 years on this campus who actually did a longitudinal study. He collected his predictors at the beginning of the school year. He waited until the end of the school year to collect the outcome, to do a prediction. Whenever you claim to do prediction, it means the predictor, either you collected data earlier or that it happened earlier. See the difference? Because if I ask you what was your GPA at the undergraduate school, I'm asking you now, but your undergraduate GPA belongs to the past. So I can use the undergraduate GPA to predict, for example, graduate GPA. But if you are taking two courses at the same time, you are taking stat and quantitative methods. It's at the same time. I cannot use one to predict the other one. See the difference? I can use one to explain the other one, but not prediction. So this, now go up, go back up.
Go back.
Yeah, I just want to say this retrospective, also called cross-sectional, and prospective are also longitudinal studies. Okay. So again, picture this proposal you are writing. You have identified your research question. You have identified your design, how you plan to do the study. Then you get to subject selection. You have to have a heading as to where are you going to recruit the subjects and how you are going to do that. So what is frame? Frame is what you use to identify your population. You have to have a listing of people. So for example, you want to do a study here in Corpus Christi, you may decide to use the telephone directory as the frame of the study. So whoever is listed is going to be in your population. Then what's the problem with using telephone directory to identify the residents of Corpus Christi? Not everyone is listed in the telephone directory. But you acknowledge that particular limitation. You want to do a study here on this campus, for example, studying the faculty. You go to the provost office, maybe they agree to give you the listing of faculty. Depending upon when was the last time they updated the listing. There could be some faculty who are not in that listing. There could be some who are in the listing, but they are no longer here at A&M Corpus Christi. I have a student, her proposal is at the IRB, and she wants to survey the GED graduates. So the frame of hers, there is this program here I don't remember the name of the Freedom is, there is a program here for GEDs. People who are going to be in her study are the people who are in the mailing list of this particular organization. And she has already talked with the director. The director said, I'm going to help you. I'm going to provide you with the email contact information so you can contact the people. So that's frame. So you use the frame to identify the population. Theoretically, we distinguish between target population and accessible population. Target population is the ideal population. Accessible population are the ones that you have access to. So this student, for example, she's interested in GED graduates. But what she gets, that's her accessible population. In real life, we work with this. Accessible population. You may not see the wording when you read. You probably have seen the population for this study consisted of. It's very rare for you to have seen the target population or the accessible population. But for academic purposes, we would like to know that there is a target population and there is an accessible population. Then when you have the population, you get your sample. So what is population validity? This is a big claim to make. If and when you claim population validity, it means your sample is representative of the population. And as I said earlier, most research we do in education, in applied behavioral sciences and all that, our sample is not representative of the population. So be careful with that. Okay, go ahead. So we have two types of sampling. We have non-random, non-probability sampling, and then random probability sampling. Non-random, non-probability sampling, not every element of the population has an equal chance to be selected. So as I said earlier, you are not selected at random. So you are a non-probability or non-random sample of graduate students at Texas A&M University, Corpus Christi. There are different types of non-random, non-probability sampling. Convenience sampling, as the name suggests, you select subjects based on the availability. You want to survey the students here. You go stand at the entrance to the UC. As they walk in, you ask, okay, I want to do a survey. You have to get their agreement, consent. You cannot just. So while you are trying to encourage this person to be in your survey, there will be lots of students going in and out. So that's why it's called convenience or, well, not sampling. And as you imagine, that sample is not representative of the population. Coda sampling, you state the code. You say, okay, I want to have 25 Hispanic male, 25 Hispanic female, 25 white male, 25 white female, and so on. You continue your data collection until you meet the quota. So something like that is not representative of the population. Purposive or judgmental sampling, these are the people who are going to provide you with the best information. You do this mainly in qualitative research. Because qualitative research, your sample size is not going to be more than 4 or 5 people whom you want to interview. And they have to meet lots of specific criteria before you decide to invite them to be in the study. Network or snowball sampling, we use this to recruit hard-to-find subjects. So you recruit one, then you use that person to recruit others. Many, many years ago, this was in the 80s, when I was in Miami, Florida, I always remember that example. We were working with recovering cocaine addicts in Miami and Miami, Florida. Once we had the recovering addict, they were telling us about other addicts. But they know each other. They could even tell us, okay, we meet there, come. And so then we were going there to recruit other recovering cocaine addicts for the study. That sample would not be representative of the population. Finally, self-selected, this is when you ask for volunteers. And volunteers do not represent the population. So there isn't anything wrong with doing any of this. You just say it, and you report it, and then you also include the limitations. So the big limitation here is due to non-probability nature of sampling, the extent of validity is limited to participants. A standard sentence you will see in the dissertation of all the students who have worked with me and in our quantitative studies. Both in chapter 1, you have a section, limitations, delimitations, assumptions. Then when you get to chapter 3 on subject selection, then when you get to chapter 5, when you have to conclude, and then you let the reader know to whom you are generalizing the study. I keep using the word limitation, delimitation. Do you know the difference between limitation and delimitation?
I don't know what
Okay. I'm not surprised, but no one asked. But then that's okay not to know, knowing that lots of people don't know that. But you need to know. Delimitations are the ones that you control. Okay, that's delimitation. So if you decide to study first graders, that's a delimitation. The study is delimited to first graders, or the study is delimited to Hispanics. Limitations are those that you cannot control. So you heard me saying that the extent of validity is limited to participants, because as a researcher, you cannot control who is going to be in your study, who is not going to be in the study. My student, the one I was telling you about studying recess, so her study is delimited to reading and math achievement. That was her prerogative. That I want just to look at reading and math, and also delimited to fourth graders and fifth graders. And there is justification, by the way. You cannot just say, well, I just want to study eighth graders. We don't let you do that unless you have a justification why eighth graders and not seventh graders. Okay, thank you. Then we have random or probability sampling. These are the samples which represent the population. Ideally, you would like to do this. But again, the likelihood of being able to do it is very difficult. Simple random sampling. You identify the population, assign a number to them, go to the computer and find a Google random generator, and it would generate for you the subjects at random. Like I have a population of 875, from 1 to 875, and I want a sample of 100. It will select the 100 at random. I still have students sometimes say, well, yeah, I put the numbers in a hat and I draw at random. You have to have a very big hat to have 880 numbers and then go and grab. But that is a simple random sampling. In a course in statistics, you will learn to estimate the sample size. Obviously, I cannot do it in a 90-minute. So it's not a guessing game. It's not like, oh, I need 100. Or I think 100 is a good number. That's not how these things work. You specify parameters, and based on those parameters, you estimate the sample size. You learn those in either a statistics or in a research methods class. I teach them in my stat class. Systematic random sampling, this used to be popular before we all could carry mobile devices and all that. This is like when you are out in the field and then you want to draw a random sample. And in the old days, you had to go to the table of random numbers, which is at the back of any stat book, but here you are. So why we do that? For example, you want a sample of 200 from 2000. 2000 divided by 200 is 10. Then I go to the subject. I say, okay, give me a number between 1 and 10. The person would tell me 7. So number 7 is the first, and then I go increments of 10. 17, 27, 37, 47, 57, and I go back until I get the sample that I want. This is systematic random sampling. The stratified random sampling, okay. Stratified random sampling, you divide your population into strata, into groups. And then you select the sample from each stratum. So for example, you divide the population of faculty here into assistant professors, associate professors, full professors, and then select your sample from each stratum. We have proportionate stratified sampling. We have disproportionate stratified sampling. Proportionate, easiest way to explain it by giving you an example. We have a population of 20,000, which is divided into 4 strata. A strata is plural, a stratum is singular. So stratum 1 has 6,000, and then 4,000, 4,500, and 5,500. Then we want to get a sample of 1,000. So 1,000 divided by 20,000 is 0.05 or 5%. Then you get 5% of your sample from each stratum. So then you will see the sample size is 300, 200, 225, and 275. These are in proportion to the total number. Disproportionate is the opposite. You pretty much go and then go say, I want 1,000, so 250, 250, 250, 250. If you know the number for each stratum, what is recommended to do is proportionate stratified sampling. Before you propose to do this, you say, okay, I want to study like different universities and get the population sample from each university. Some of these things sound good in the paper. Then you realize I have to go into each university's IRB committee, get permission, and then, okay, no thank you. Make sure you work within your resources. And in a doctoral dissertation, in a master's thesis, you are not expected to solve all the world's problems. So you plan to do something which you can complete it within a reasonable time. And the committee will be understanding, especially the committee that there are people with, at least, your chair, it will be someone with experience in doing this thing. So just sometimes remind yourself, small is beautiful. And when you get your degree, you move on, then even when you become a professor somewhere, at the beginning you are not going to do a big study. You are going to do what we call feasibility study. Get a little money from the university to do a pilot project, and then from there move on into larger grants. I just finished yesterday reviewing 7 applications for what we call research enhancement here at the university. These are like $5,000. It's not lots of money. But there's competition because it's 7 applications, there's money for 2, maybe 3. But those are the smaller studies. And these are mainly younger faculty who start with doing studies like that. And then you use the results from these smaller studies to write grant proposal for more money. No one is going to give you big lots of money without showing them some evidence that you have paid your dues. You have done some studies that you can rely on to apply for large sum of money. Single stage cluster sampling. Now the unit of analysis is a cluster. Cluster is a unit. Like this is a cluster. So someone can pick, and at random, what is this room? Library 220, room 220. They come here, say, okay, you're all in my study. please complete the survey. That is single stage cluster sampling. The example I have given you, we want a sample of 1,000, and there are 100 nurses in each hospital, so you pick 10 hospitals, go and include all the nurses. That is a single stage cluster sampling. Multi-stage random sampling, I jump from here to here before going back to this. Here you pick the hospital, then you go and include everyone. That is single stage. But if you go to the hospital, then randomly select the nurses. See the difference? All versus a random. Then you do what we call multi-stage random sampling. Multi-stage cluster sampling, these are all clusters. And you go at multi-stages. For example, I have given you, you select the state at random. And then you move on to the university and then to faculty members. Next, please. I think this is for me. Okay, here you are working on your proposal. You have decided on the design, you have decided on the subject selection. Now you have to measure the variables of interest. So there is a section in the proposal called instrumentation. You can take a whole course in instrumentation. In my research methods class, I spent a couple of weeks on instrumentation. Instrument is a generic term for whatever it is that you use to measure the variable of interest. You go stay in a hotel. Later, they send you a link to go and let them know how you felt about staying in the hotel. Nowadays, even when I have an oil change done, I get it from Honda. Go and that's an instrument. That's, you do the measurement. In the morning, if you have the courage to stand on your scale and weigh yourself, so then you measure your weight. When you go for your annual checkup, they measure your weight, your blood pressure. So these are all instruments. In instrument, you have to pay attention to the psychometric properties of the instrument. So one is validity. Validity is to show that instrument measures whatever it is that you claim it is measuring. So that's validity. It's a big claim to make, and you have to substantiate that. There are different types of validity. One is called phase or logical validity. It's like this is an instrument, and you look at it, so it looks fine. Essentially, that's all you're doing. Don't expect anyone accept phase validity as the only evidence of validity. So why are you telling us about something which is not good, so that you won't be tempted to ever use just phase validity as the evidence of validity? Or you are reading someone's paper, the only evidence of validity provided is phase validity. Then we have content validity. Content validity is much better. Content validity, you usually have a panel of experts to examine the content validity of your instrument. You develop your instrument, you tell the panel of experts, these are my research questions, this is what I want to measure. And does this instrument measure what I'm trying to measure? You don't have any empirical evidence, but at least experts are going to approve that. Then we get to criterion-related validity. Now you begin having empirical evidence for your instrument. Can you go up a little? Thank you. So in criterion-related validity, you have your test, you have a criterion, and you have to show a relation between the test and the criterion. So for example, if you say GRE is predictive of success in a graduate school, you have to show a relation between GRE and GPA in the graduate school. So essentially what you have is a validity coefficient. Validity coefficient is nothing but a correlation coefficient between the test and the criterion. The Goodall Pearson R that you compute, we just call it validity coefficient. We distinguish between concurrent validity and predictive validity. The test which claims has concurrent validity, it estimates present standing. It's good for diagnosis purposes. The example I have been using for all these years, I feel sorry for Johnny, that Johnny is neurotic. You give a test based on that to say, well, Johnny is neurotic, or Johnny is depressed. That's concurrent. Predictive future performance is good for the purpose of classification or selection. Johnny is likely to become neurotic. So some schools, they give tests with predictive validity, the likelihood of this student passing at the end of the year. So if the student needs immediate attention, for example, they put the student in remedial classes. So the next time you read, whenever you have an instrument, it comes with a manual. And the manual talks about evidence of validity and reliability. Then pay attention. When the authors claim that the instrument has criterion-related validity, and then which one? And then based on that, then you use the instrument. The one which is the hardest to establish is construct validity. Construct is something that you cannot see it, but you want to be able to measure it. Music appreciation. Can you see music appreciation? No. Can you see anxiety? Can you see depression? I mean, you can see someone who looks depressed, but we would like to measure depression or social support or music appreciation or happiness, all that. My student, the one who is going to study GED, she wants to measure servant leadership characteristics of GED graduates. So you have to have an instrument to measure that, and then you have to show that the instrument has construct validity. So when you get to your study, at the beginning, try to find an instrument which is been tested, which is published. Use that. Otherwise, you have to develop your own instrument, and it would take time to establish its validity and reliability before the committee will let you collect the data for your actual study. My student GED, she found a published instrument. And there are instruments. This is the land of instruments. So before trying to develop your own, do a search, see if you can find it online. Now go down. So there are different ways to establish construct validity: convergent validity, discriminant validity. Convergent validity, if theoretically speaking, you expect a relationship between A and B, measure A, measure B, correlate them, they should correlate. That's an evidence of convergent validity. I have given you a couple of examples. Discriminant validity is the other side of the coin. If you hypothesize that there is no relation between A and B, measure A, measure B, correlate them, that correlation should be low or negligible. Example I have given you is between scholastic aptitude and musical aptitude. Theoretically, there is no reason for someone who is high in a scholastic aptitude to also be high on musical aptitude. A very popular way to establish construct validity is factor analysis. I just show you the name. Because you need at least one session, 3-hour session, to learn to do factor analysis. And then another way to establish construct validity is experimental intervention. For example, you have a test which is designed to measure test anxiety. Okay? Have two groups. This group, they are going to take a test. So they are going to take a test 3 weeks from today. So today I'm going to give them the test and measure their anxiety. Next week, okay guys, we have a test in 2 weeks. I measure their test anxiety. And then third, if it measures anxiety, what should happen? The anxiety should go up. I have a comparison group. They are not going to take a test. So I administer the test anxiety questionnaire. Week 1, week 2, week 3, there shouldn't be any change, correct? They are not going to take any tests. So if I can show their anxiety score change, because they were going to have a test, but not this group, that means the instrument was sensitive to capture their test anxiety. That is experimental intervention. So this is validity. Next is reliability. Reliability is poor man's validity. Poor man's validity. Why do I say that? If someone else said it, I just remember it. It's much easier to establish reliability than it is to establish validity. So you read, there is lots of information about reliability. You go to a conference, someone comes and just talks about reliability. Great. You have the right to raise your hand. Okay. You told me enough about reliability. What about the validity? Validity is a big one. Validity, it shows that you actually measured what you are claiming to measure. Reliability refers to the consistency of the instrument. All the items contribute towards the measurement of the same variable. We don't live in a perfect world. There is always error in measurement. We have systematic error and we have random error. You would like to know the difference. Systematic error, you give a test, everyone fails it. Or everyone aces it. That is systematic. Random happens at random. I'm sure in your academic life there was time that you had to take a test, but you didn't feel well, but you still went to the class and took the test and end up not doing well because you were not feeling well. That is a random source of error. But we have error. There is never a perfect correlation between X and Y for you to claim that there is no error in measurement. But reliability would show you that error, if your test has reliability, means that error is low. So there are different ways to estimate reliability. Can you go up? Okay. And if you ever want to impress a measurement person, when you get to reliability, use the word estimate. Okay? He or she would love it. Because we estimate the reliability. You never have the perfect number.
Don't say establish, say estimate.
Well, estimate. Yeah, you are out on a date with a measurement person, and this makes the, So there are different ways to estimate the reliability. Test, retest reliability. We do that to establish the stability of the instrument. You test, and then you retest. Correlate them should be high. That means the test is stable over time. When I say test, I'm not necessarily talking about a test that you take in stat, for example. Actually, something like that we don't want, stability doesn't apply to it, because it's the same test, same measurement. IQ, it should have stability. You cannot be smart one day and next week not being smart. So we test and retest. What should be the time between test, retest? Something reasonable, and you report it. There's no magic number. Should it be 5 days, 5 weeks? Shorter the time, you expect the reliability to be higher. Equivalent form. Have you heard of a test with different form, form A, form B, form C? Okay, those tests should have equivalence. How do you establish that? It's pretty easy. I have 3 forms of tests. I give you form A, give you a 2-minute break. I give you form B, and then I give you form C. I correlate. If the correlations are high, then there is equivalence. Now, if you have the 20 items, rearrange them, you don't have an equivalent form test. It's the same test. You just, question number 1 is not question 10. When you claim you have equivalent, same number of items, but different items, but they all measure the same thing. So if you have 3 sections of a class, you can use form A with your morning class, form B with your afternoon class, form C with your evening class. And published tests, they come with different forms.
So they don't necessarily have to be given to the exact same people, all 3?
Well, to establish the equivalent, you give them to the same people.
Okay. But actually when using it?
Then when I know that the 3 forms are equivalent, I give you form A, I go next door and give them form B, for example, like 2 hours later. So if you run into them on the way to the parking lot, you're not going, oh, okay, question number 5, answer is, So if I just give you form A and form B, I establish equivalence. If I give you form A and form B next week, I establish both equivalence and stability. The most popular measure of interconsistency is this Cronbach's coefficient alpha. It ranges from 0 to 1, closer to 1, the stronger the reliability. It's pretty easy to run it. You just sit in front of the SPSS, just identify the items, run it. A split half reliability shows that reliability is a function of the length of the test. As you make the test longer, you increase the variation, you expect your reliability to go higher. So there is a formula called the Spearman-Brown prophecy formula in a measurement class. You learn it. My students, I taught them how to, and they remember it, by the way. No, they don't remember it, but they know where to go in their class notes. And here is the Spearman-Brown prophecy formula to, you estimate, you have the reliability for 10 items. You say, okay, what will happen if I increase the number of items from 10 to 25, for example? And then it would show that it would increase. Can you up? So we can summarize all this in this 2x2 table. 2 forms of tests, 2 test sessions. So if you have 1 form of the test, but administer it at 2 points in time, that is the coefficient of stability, test, retest. If you have 2 forms of a test, but administer it at 1 point in time, like I give you form A, followed by form B, I have the coefficient of equivalence, immediate administration. But I have the 2 forms of tests administered at 2 points in time. I establish both the equivalence and the stability. And if I have 1 form of test and administer it at 1 point in time, that's the internal consistency. The most popular one is the Cronbach's coefficient alpha. So that's the instrumentation. When you write your proposal for your thesis or doctoral dissertation, in the instrumentation, you have to address this thing. It's how you plan to tend to validity and reliability. And of course, all these things done, then you have to pilot it to make sure that your instrument works. Nowadays, especially that people use online My student, the one who's doing the servant leadership, I was impressed. I don't work with Qualtrics, but we use on this campus Qualtrics. And then she emailed me a couple of days ago, Dr. K, I have never done anything Qualtrics. Oh, go and play with it. Following day, she sent me her instrument in Qualtrics. She had created her online survey. She sent it to me. I said, OK, now we have to pilot it. I'm going to complete the survey, just make sure it works. You prevent huge disasters by pilot testing your surveys, especially online surveys. Trust me, I'm not trying to scare you. You have to pilot it, make sure you can download the data. And when you download them, they make sense. For example, if you have attitudinal items, strongly agree, agree, disagree, strongly disagree, and then you have 50 of them, there should be 50 columns with one entry, correct? Strongly agree, agree. Some years ago, one of my students, I'm glad we piloted, the way he had programmed it was for each option, it was giving different columns. So like, for example, it was a strongly agree, and then blank, blank, blank. Blank, agree, blank, blank. Can you picture it? It was a mess.
Can't figure out how to answer.
Well, we noticed it. He noticed it when the instrument was pilot tested. So when Sylvia sent me, and it worked. Because you get the consent online. They have to agree. If they agree, they can complete the survey. So she programmed it. If they said disagree, it just sent them to the end. Thank you, bye. And so pilot test your instrument. Data collection, I won't be done in 90 minutes. So I stop. If you want me, I continue. If you're tired, then data collection, existing data. We have lots of students in our program. They use existing data. For example, say STAR, reading, math. They just go to the school district and get the data. Easier said than done, by the way. They have to go through some steps to get the data. Online mail survey. I don't have many students do mail survey anymore. There's online, but there is a problem with online. The problem with the online is they send a link. No one is going to click and open the link unless you keep sending. My students here, both in the EDLD and in CNI, after 6 weeks, 7 weeks of data collection, they come back, I got 5% response. Then email the committee, this is what all the students could collect. Does she or he have the permission to move on? The answer usually is yes. So it goes back to what I was telling you earlier. The extent of validity is very limited. So when it gets to this online survey, if you know of an organization, for example, who is willing to send your survey out on behalf of you with name recognition. So Sylvia, this founder of this organization here, he has agreed to send out her survey. It's more likely for people to open. I get surveys from APA, American Psychological Association, AERA. I open them. I trust the sender. Nowadays, you're afraid of clicking. Keep that in mind. Telephone survey is another one, group administered survey. I had 2 students who were very successful with this, actually, a few years ago. They went to schools. They made an arrangement with the school principal to have the students in the cafeteria. And here I had 2 students. They went to classrooms. They got the permission from the instructor, went to the class, gave them the survey. Please leave it there on your way out. It's still not representative, but actually, at least they could get subjects. Personal interview, that's qualitative. Focus group, We have students who do this, especially those who do mixed methods. Observation, mass media, biophysiologic measures. Can we go up? Yeah, you want to. Yeah. This is the most objective measurement. Doesn't apply to what we do in education, but when you do your blood test, that's pretty objective. The scaling. Okay, guys, this is pronounced Likert, not Likert, even though you have heard it to be Likert. So don't be afraid in the future, say Likert, knowing that someone is going to correct you. It's Likert. It's the name of the person. How do I know this thing? 1979, I was a graduate student at the University of California at Davis. So I was working on my master's. It was a zillion years ago. We had a visiting professor from London School of Economics. And he was talking about all this. So when we got this, we all said Likert. And he gave us this look, like you Americans, you cannot even say the name of the. And he knew Dr. Likert. And if you Google it, actually, the pronunciation says Likert. Okay, this is a Likert scaling, and you have seen them. I belong to the group of people who don't like undecided option. Strongly agree, undecided or neutral. I don't like that. It's not personal. It's shown when you give an option like that. Many people pick that, taking an easy way out. It would homogenize your data. If you end up with a homogeneous sample, nothing is going to happen. Another thing I have noticed in some of our students' results, they end up with a very homogeneous sample. So keep that in mind. But that will be up to your methodologists on your committee. So if he or she insists on neutral, go with that. Don't say, well, this guy told us that's not a good option. Commonly used tests. You all know what is intelligence test. You all know what is diagnostic test. You all know what is personality test. Aptitude versus achievement. Still, some people confuse these two. Aptitude is to estimate future performance. Achievement is to assess a status upon completion of the task. This is what you test at the end of the semester, for example, or at the end of the unit. Okay. I had requested 90 minutes. Obviously, my 90 minutes is up. You want to stay? I'll talk about this data analysis part. You want to leave? Those who want to leave can leave. Those who want to stay, I'll talk about it. It's up to you. I requested 90 minutes, but this is pretty much a data analysis part. What's your wish? You want to stay?
Can some go and some stay? Is that okay?
That's what I said. If you want to leave, leave, but make up your mind and leave now.
Thank you.
You're welcome. Oh, this is a sample of chapter 3 of Alyssa Mejia. She graduated from. Let me give you one of these in case you decide to leave. Anyway.
Thank you.
When you get to the data analysis phase of the study, in the proposal, you have to propose as to how you are going to analyze the data, and then in the final document, you specify how the data were analyzed. The example I gave you, for example, This is from her dissertation, not the proposal. You can read and see. This is a decision tree. I put together this some years ago. There are examples of these decision trees in most stat books. At the beginning, ask yourself whether your data are continuous or categorical. That's an easy decision to make, whether you have interval ratio data or nominal ordinal data. You learned that in Stat 101. So if the data are continuous, which we call them measurement data, ask yourself, am I interested in finding differences or in testing relationships? Just look at your research question. It will tell you what it is. So if you want to test differences, if you have two independent groups, you do the t-test for independent samples. You learned that in first stat course. If you have two dependent groups, like comparing pretest with post-test, you do t-test for correlated samples. If you have more than two groups, then you do analysis of variance to compare two or more groups. And then you do analysis of covariance. If you want to, remember I talked about confounding extraneous variables? One way you can statistically control for that is to do covariate analysis. You adjust the outcome, for example, on the basis of, say, age, or on the basis of pretest. Here, or t-test or one-way ANOVA or factorial ANOVA, there is one outcome. If you have more than one outcome, then it's called multivariate analysis of variance, or you can do a discriminant analysis. You learn this not in the first stat course, second or maybe third stat course, depending upon where you are. Go down, please. So these were differences. If you are interested in examining relationships, in doing correlational study, if you have two continuous variables, it's a good old Pearson product moment correlation coefficient. Several predictors, one outcome. If the one outcome is continuous variable, it's multiple correlation and multiple regression. If the outcome is binary, you want to predict pass-fail, that is logistic regression. If the outcome is a categorical variable with more than two levels, it is discriminant analysis. And if you have several independent variables, several dependent variables, is that canonical analysis that I was telling you. You need to sit down with the methodologists. If you don't know it yourself, well, you should have pretty good ideas, especially if you have taken the stat courses. And your committee, your chair, relies on your consultation with the methodologists, essentially. And sometimes, most of the time, the chair even leave that to the methodologist. It's between the student and the methodologist. If the chair is not into statistics, the chair doesn't have to be a statistician. That's why, for example, people like me serve on dissertation committees. And then it's our responsibility to make sure that the student collects, analyzes, and interprets the data correctly. So once, for example, I email the chair, I say, well, I'm done with chapter 4, chapter 3. From now on, she or he is on your hand. I'm done. Go and deal with the student. Deborah, go and talk with Dr. Brun from now on. So these were pretty much parametric statistical techniques. If the outcome is categorical, essentially nominal, ordinal, then you have to go into non-parametric statistical techniques. Go down, please. Just go all the way to. Okay, let's stop there. Ask yourself the same question. Differences, if you have two independent groups, the outcome is ordinal, rank. There is a technique called Mann-Whitney-Wilcoxon U-test. If the outcome is nominal, is a chi-square goodness of fit. You learn about chi-square goodness of fit and chi-square test of independence, usually on the first stat course. Mann-Whitney, you either have to take a course in non-parametric or is included in a stat course. I cover them in the stat course that I teach, the second stat course, because we don't have a course specifically for non-parametric. Two dependent groups, outcome is ordinal. There is a test called Wilcoxon match pair sign rank test. If you have dichotomous nominal data, there is a test called McNamara. Analogous to one-way ANOVA is a Kruskal-Wallis test for ordinal variables. If the data are nominal or count, there's a chi-square goodness of fit test. Multiple dependent groups is a test called Friedman test. Chi-square, just a quick review, you learned that in first stat course. Chi-square goodness, no, it's underdone. It's next one. And then you will learn to compute what we call effect size for all these techniques. Have you heard of effect size? This is nothing new. This probably at 25 years ago, decision was made that we cannot only be interested in a statistical significance. We are more interested in the practical significance of our findings. Nowadays, good journals, if you don't report the practical significance of your findings, they don't consider that for publication. So what I talked earlier, t-test, ANOVA, all that, you can compute the effect size. We teach them in a stat class. Relationship, if you have two ordinal variables, there is a technique called Spearman rank order correlation coefficient or Kendall-Top. If you want to examine inter-judge agreement, there is a technique called Kappa coefficient. You send out raters to go to classroom, observe teachers, and rate them. If I want to send these 5 raters out, I have to make sure there is an agreement. It's not like one of them is very liberal, one of them is very conservative. So we have to either send them all to same class or show them the same video. Ask these 5 to rank it and then correlate them to establish inter-judge agreement. 2 binary variables, like 2 by 2, is a chi-square test of independence. And then if you reject the null, then you have to get the phi coefficient to describe the magnitude of the relationship. If you have cells with expected frequency less than 5, there is a technique called Fisher's exact test. Actually, SPSS automatically gives it to you for 2 by 2 tables. Row by column, anything other than 2 by 2, again, you still do the chi-square test of independence. If you reject the null, you are saying that there is a relationship. Then the magnitude of the relationship is described by Kramer's statistic. Finally, if you have several related samples, there is a technique called Kendall coefficient of concordance. So this is a summary of 2 stat courses, by the way. Okay.
We're not supposed to keep all of this in our head, right? We just know where we can get that information in the books.
No, I'm sure your head already hurts. You know.
I went through both stats courses.
Just as you walk to your car, don't shake your head. It can ooze from your ears, you know, stuff. Go down one more page. I'm pretty much done. But this is just some information. You all have to complete the city course. If already you haven't done it, do so. Because when you submit your IRB protocol, if you don't have the city certificate, they won't review your IRB protocol. City is good for 3 years. I have completed my city 3 times. I just had to do it like 3 weeks ago or 4 weeks ago. I submitted one of my students, and I realized my city had expired like 2 days earlier. So
there's a refresher course available, right?
Well, that's the one actually.
Okay.
Yeah. But just make sure your city is up to date. And then the IRB. There are 3 types: exempt, expedited, full review. And you can go to the IRB website. This is the link to the forms. And exempt means it doesn't go to the IRB committee members. Expedited does not necessarily mean it be done quickly, but it means it will go to 2 committee members, and then they either approve it or they send it back to you with some revisions. And then full review, IRB committee here meets once a month, and you have to keep that in mind as to when you submit your IRB protocol. And I have listed some references. Go take it to the top. The book by Cohen, Anything About Sample Size Estimation, is there. This book doesn't age for as long as there is civilization on Earth. Cohen, 1988, will be reference. He passed away, and probably no one in his family has the permission or to update it. There is no need to update that book. This is the book I use in my stat class. He now has a new chapter, newer version of the book. It's self-explanatory as to what these books are. This book, I like it. The book by Pedazor and Shumelkin, 1991. They never came up with a newer version. This is a father and daughter. And you can find answers to probably 90% of your measurement, design, and analysis question in this book. I don't like it as a textbook, but it's an excellent reference book. It's this thick. You probably still can find used versions of this book. Okay. Thank you for your attention. I didn't do that badly. It's 20 minutes over the